And good afternoon and good morning and good evening to everyone. This is going to be a bit of a practical presentation on the cybersecurity in the AtoN industry. And to have a look, just hold on, let's see, my slides are working here. Give me a second. So to have a look at where we stand with the cybersecurity in the AtoN industry, we have to have a look at the past and our connectivity solutions we've used in the past few years. And from this, we can determine our risk profile for each technology used, the applications we use behind it, and also to see what our preferred technology is and what risk mitigation strategies we should be using. So historically, AtoNs were unmonitored and relied on human observation to determine outage. And this was probably the industry norm many years back. And over time and through technology advances, this has changed to a connected solution. So back in the day, probably one of the first technology solutions was the public switch telephone network. And then from there went to RF and GSM. And traditionally, these were all closed networks. So we had all these assets or AtoNs going to a central hub and being monitored by an operator. And this is, however, changing. So right now, we're getting to a point where you'll hear this words out there between IT and OT technology convergence. And this is due to the fact that, as Jose said early on, everybody is making an IoT device. This is based on current IT networks. And because of this, OT networks had to follow suit. So OT networks are your traditional networks designed for operations, for safety, for security, for reliability, and generally done by Siemens and ABB and those likes. So to compete with them, technology has converged, where right now they're using the same IT technology. Historically, they were using Profibus or Modbus RTU. So which that means right now that we have now a fully hybrid network. So we have a network that can consist of IT sensors, or IoT devices, and SCADA devices or traditional PLCs. So this means we can access it anywhere from the fingertips of our phones. So going back, what was the first connectivity solution? That was probably the public switch telephone network. It's now a legacy device. Many countries are phasing it out in favor of VoIP. And back in the day, you probably have several options for connectivity. This could be circuit switch dial-up interfaces or X25. And it was generally an alarm monitoring solution only. So for instance, because an asset had a dial-up, it was not real-time, couldn't provide any real data, only used for alarming. And this might be strange for many people, but it depended on coverage and how far you were from the local exchange. So where PSTN networks couldn't service, we had RF networks, and RF networks took over as a very preferable solution for many assets and became popular as a last mile solution, specifically in AtoN from the coast to a buoy. However, it does require regulatory approval in most countries except for the ISM band, and because of this, the ISM band has become extremely congested, not only because of everyone using it for AtoNs, but because of Wi-Fi and IoT devices. So, which meant that many operators have spent more time servicing RF links and actually making sure it's more reliable than the asset itself. And moving on from RF networks, we have GSM networks, and it provides a reliable service, and it's become probably the industry standard and de facto standard for AtoN monitoring. Unfortunately, still limited coverage in many areas, and due to the quick technology refresh cycle means many operators are still playing catch up. So as we all know that many AtoN devices are on service for 15 to 20 years. So if you had deployed your network possibly 15 years ago with a modem in it, you're probably playing catch up. You know, you've done the change from 2G to 3G, and you're doing the change right now from 3G to 4G as the operators are shutting down their networks to make way for newer technology. And then we have IoT. These devices use traditional IT networks such as Wi-Fi or Ethernet stacks, and also Bluetooth and Zigbee have become very, very popular because of their low power. And because of the low power, range is a limitation, but they've been designed to work from a connected hub, so just as a small last mile solution in a factory or somewhere, or just for weather sensors on a buoy. So low range, low power, connect to central hub, and the central hub will then relay that information across to somewhere else. And let us not forget satellite. So initially, this was cost prohibitive. Many years ago, 1 megahertz of space segment would set you back several thousands of dollars per month to rent. But the cost has come down with multiple players in the market now. And also with technology advancements, if you're looking at, for instance, DBS or other modulation schemes, we can now get more data per megahertz than ever before. So cost has come down on that. And if you're looking at different types of orbital slots, you do get the LEO orbital slots, the medium Earth orbit slots, and the geostationary Earth orbit slots. And this is important to know the different types of orbit slots we do have, because they do impact your latency. And for instance, if you're looking for real-time communications, you may not want to go for a geostationary satellite. And so generally, satellites do provide really good coverage. So they are the preferred option for remote locations or locations that do not have any existing GSM infrastructure, and make a good option for offshore locations. So as we've seen over the past few slides, technology has enabled automation. So from your legacy person that was viewing the AtoN or the light to make sure was on, now to almost fully automated system. So which means we have now a more reliable means of monitoring. And because of this, we can do remote diagnostics, real-time monitoring and alarming, which has led to reduced costs and maintenance, has led to longer duration between preventative maintenance cycles, and is all helping us to achieve our EALA availability targets of less than, I think, 17 hours per annum per asset. So if you're looking in the AtoN industry, we have different types of assets we're monitoring. We're monitoring the signals on buoys and possibly meteorological sensors. And we have all these different types of technology and connectivity options to link us up, for instance, RF, GSM, satellite, and even IoT for our weather sensors. And you're looking more on the shore side, we have lighthouses and shore beacons. Again, we monitor full system performance and outages, and with different types of connectivity options available, such as PSTN, GSM, and satellite. So with all these assets out there, I mean, it's nowadays people will have not one or two assets, they'll have several hundred assets to monitor. And it makes sense to have some sort of data management platform to monitor your assets. So if you look at the technology we have, we looked at the last mile solution, and we're looking at now the application. All of these are subject to some sort of cybersecurity threat or some sort of exploit. And it's for us to determine where the risk lies. So if you're looking at risks to AtoN, we obviously have the deliberate risks. So generally we have cyber attacks on businesses and infrastructures. I mean, and they're becoming more prevalent over time. And as you can see on the graphic here on the right-hand side, I mean, these are just threats that or attacks on different companies over the past several years. You can see just in this year alone, Facebook has had over 533 million attacks against them. And Facebook is not alone. There are many other companies that are experiencing the same attacks as them. So I do want to talk about some notable infrastructure hacks. If you just look at last month, in the month of October, we had an Iranian cyber attack on a petrol station. And this was a terrorist attack where they decided to shut down the payment system on the petrol stations. And this caused mass queuing at the petrol station, mass panic. No one could fill up the petrol. And this was not for money. It was just purely governmental. If you're looking back in May of this year, we had the Colonial Pipeline hack. So this was more of a ransomware attack where hackers gained access to the management and operating system of the Colonial Pipeline company. So in order to thwart the attack, the company decided to stop all operations. And we all know what happened since then. We had mass panicking, buying, queuing at petrol stations. The petrol prices went up substantially. At the end of the day, to get the services back, the Colonial Pipeline Company paid the 75 Bitcoins to resume their services. And we've all talked about Stuxnet. This was probably the original computer worm done 10, 15 years ago. This targeted the nuclear power station in Iran. And I do want to highlight this one. This was probably the first operational technology hack that happened that was publicly disclosed. And this was done by a governmental organization. So as said before, some of these are sanctioned by governments. Others are through rogue groups such as Anonymous. Not all of the hacking groups are there looking for money. Some of them are just looking to do something because they can. And if you again look at this graphic on the right-hand side, you can see over the past 10 to 15 years, the exponential growth in malware. So 10 years ago, 15 years ago, when you were deploying an asset, you weren't even considering cybersecurity as part of your security strategy. Now it's a must. And if you're looking at the top current targets or threats, these are in energy, transportation, mining, construction. These are lucrative industries for attackers to target for ransomware. We also have technology risks. So looking at the original slides, we have PSTN, we have RF, we have Zigbee, we have Bluetooth. They all have known exploits against them. And for instance, for GSM, there's a known SS7 exploit. And for mobile devices, we have the Pegasus hack from NSO Group. And NSO NSO Group has been in the news of late. They're known for all their attacks on world politicians, on spying on them. For instance, if you're looking at Bluetooth, Bluetooth can be scanned. There's numerous hacking applications out there that you can download, for instance, on an Android phone. You can sniff the network and you can intercept. PSTN, Wi-Fi, TCP/IP are all prone to man-in-the-middle attacks, and RF can be intercepted. Just think that an RF link is an open channel. Anybody with an antenna can point to your link and intercept what you're doing. So if you don't have any encryption, it makes it a lot easier for hackers to actually understand and decode your data. We also have accidental risks. So these are mainly human factor risks. So for instance, incorrect asset configuration or accidentally switching an asset off. We do have data corruption. So this is software updates that can take down a system. And I do want to highlight here that there used to be a thing called Black Tuesdays. And this is when, for instance, Microsoft would release their updates every Tuesday to thwart any exploits found. What would happen is hackers would take those updates and reverse engineer them and find what exploit they're patching, because many companies didn't actually do timeless updates on their systems and would then be in danger of getting attacks against them. We can have bad actors. So generally a bad actor is an asset that is in some sort of fail state that is alarming or not alarming in every couple of milliseconds. So it sends alarm, doesn't send alarm. This can be seen as a denial of service attack on your own network. So if your network is not configured correctly, it could bring down your entire network. And then we have connectivity risks. So this is generally network interference. So for instance, if you got a large network of AtoNs all connected via RF to your data management platform, anybody with an RF jammer can bring down your network, and there's probably nothing you can do about it. So what are the reasons for hacking? So ransomware currently is one of the top threats. This is a very lucrative business for many hackers. This is your system lockout virus. And the primary motive is money. Effective services is secondary. So if you're looking back at the Colonial Pipeline hack, the primary motive was to gain money. They're $4.4 million US, not to affect the service. That was just secondary. And then one of the things to note is once a company is compromised, they generally become a more frequent target. And this is due to the fact that many hacking groups do work together. They do sell lists of targets on the dark web. So it makes life a bit more difficult for companies once on that list. And just to say, terrorist attacks on AtoNs are low probability, but are high impact. But then if you think about it, what data will they get from an AtoN? The AtoN data is low risk. They're not really interested in getting to understand what the battery voltage is of an AtoN or if the light is an on and off status. So what do we do if there's an intrusion, and what we'll have access to? What technology to use for the last mile solution? And for the data management platform, which can be the weakest link, this is central to AtoN monitoring control. So if they take that down, you've lost everything. So from our point of view, we decided to use satellite communications as the last mile solution. It's a closed network, it's lower risk, it's secure, and it has L-band channel security. So by doing this, you have less attempts to eavesdrop or intercept the RF channel. And one of the bonus points, it does provide global pole-to-pole coverage for our network. So if you're looking at the data management platform, many companies still believe that self-hosting is more reliable than hosting on the cloud. I dispute that, and so generally nowadays cloud platforms are more secure and more robust than any on-prem platform. And things you need to consider is when you're designing your own platform is looking at encryption levels for personally identifiable information and possibly your asset data. So we use as a minimum AS256 for encryption, and you should be using for your hashing algorithms for storing your passwords SHA-256. One of the things you also need to be looking at is the segregation of your personally identifiable information and configuration data from asset data. Don't keep them on the same system, don't keep them on the same database. If there's a breach or an exploit, you don't want, and it's going through your asset data, you don't want them to go through and find your PII information. One of the big things to have a look at is authentication methodologies. We all know that the human factor is probably the weakest link. Many people out there still use the same credentials for their Outlook, for their banking systems, for their Twitter, for their work platforms, which makes them an easy target. So once a hacker gets your credentials, they will try on all these different platforms to see what else they can get access to. So enforcing things like password complexity, changing your password often is quite a must nowadays. And for enterprises out there, do not expose your Active Directory to the public. If you do expose your Active Directory and there's an exploit found, they can get access to your entire company network. That's your financial systems, your intellectual property, and everything else. Other things to look at is separation layers of your system. So, for instance, your database, separating your database from your API, separating it from your front-end systems. And one of the biggest things out there is to provide end-to-end encryption for your services. So if you're providing a service to an end user, make sure you use some sort of encryption, such as SSL or TLS. This is your little certificate or padlock that you'll see on many websites. And then one of the things that I recommend personally is to conduct penetration testing, not just once, but continuously throughout the system lifecycle. It's important to do this because hackers do get it more advanced, technology gets more advanced, and there may be current exploits that are not found yet in your system. So by doing this continuously, you'll be able to understand the threats against your network and provide countermeasures for that. Lastly, backup and restore management. It still amazes me that many companies still out there do not have a backup and restore management policy. So for instance, if you are under a ransomware attack and you do have a system lockout against you, you can still restore your network and resume services without paying any ransom. I put this pretty big. I mean, one of the things I do recommend is start forming a written IT security policy. Many companies I've spoken to still don't have a formal IT cybersecurity policy, and this is probably step number one you can do to start a mitigation or look at risk for cybersecurity. So in conclusion, we've seen that the technical convergence between IT and OT has increased cybersecurity attacks, but it does provide us the benefit of real-time data for our assets. And again, due to the lagging connectivity of asset technology, AtoN data is relatively safe for now, but if you are looking for the next 15 to 20 years, we need to start planning now to make sure our network is safe. And with advances in technology, consideration should be given to cybersecurity attacks from initial design to ongoing threat analysis. But it isn't all doom and gloom. I know of many industrial members that are adhering to the latest encryption standards and guidelines for AtoN monitoring in their platforms. And thank you very much.